All right, everyone, have a look up at the board here right now. This is the answers to the homework that we had last night. We had 2 projectile motion worksheets, questions 1 to 3 on both of them. The answers to the first worksheet, the answers to the second worksheet. Let's see if we need any of the 3 of those, any of the 6 of those gone over here this morning. All right, so it looks like we got to go over most of them here. That's okay. That's okay. By the way, we do want to make sure that we're okay with this, given that we are going to have a test on Wednesday. Forgot to mention that to you yesterday. Test next Wednesday on everything that we've done so far, kinematics, right up to projectile motion. But this is it, right? We don't go any further than this. This is the end of the unit here. All right, so question number 2 on the first worksheet. Question number 2 on the first worksheet says, a rescue pilot drops a survival kit while our plane is flying at an altitude of 2,000 meters with a forward velocity of 100 meters per second. If air friction is disregarded, so in other words, there's no air resistance here, how far in advance of the starving explorer's drop zone should you release the package? Sometimes it's the wording of a question that gets us. Okay, here's the starving explorers. Okay, we want to drop it so that it lands by them. Here's the airplane moving this way at an altitude of 2,000 meters. So this package that they're going to drop is 2,000 meters up in the air. The package has an initial velocity of 100 meters per second. How does the package have an initial velocity of 100 meters per second? Does the plane fire it out a rocket launcher at 100 meters per second? No, that's how fast the plane is moving. So if you drop it straight down from a plane that's moving at 100, it's going to be moving at 100 relative to the ground. So this is what's going to happen to the package. Oh, maybe we should have made it. Maybe we should have planned it to drop just short of these people, because now these poor people are starving, and now you've just hit them in the head with the food package. Let's figure out what this distance is here. How far in advance of these starving explorers do we need to drop it in order to have it land and hit by them, not hit them, but to hit by them. So let's break it up in x and y components. We have no funny angles here. That's good news. X component is always going to be delta d over delta t, and the y component is always going to be vit plus 1/2 at squared. V is 100 meters per second. We have it drawn to the left here, actually. You guys probably all drew it to the right, did you? It doesn't make any difference, right? I don't know why I drew that to the left, because usually I would go to the right so I can make V positive. I'm still going to make V positive. Okay, I'm going to pretend that left is positive here and right is negative, since everything's going to the left. We don't know what D is. We don't know what T is. The vertical displacement is negative 2,000 meters. The initial vertical velocity is 0 meters per second. 0 meters per second because it's launched horizontally. 1/2 of negative 9.81 times t squared. So what you want to do at this point is take 1/2 of neg 9.81. It gives you neg 4.905. Neg 2,000, divide it by neg 4.905, and then you want to square root that. And what do you get when you do that? What do you get when you divide 2,000 by 4.905? 20? 20.2, and then we're going to square root that. Oh, that's the square rooted answer? Okay. So it's 400 or something before you square root it. 20.2 seconds for the time that it takes to fall that distance. Whether it falls straight down or whether it falls, down and to the left or down and to the right, doesn't make any difference. It's going to take that long to fall. All right, we got 20.2 seconds. Let's put it in over here. When we multiply those two numbers together, we get 2.02, or how many digits should it be? 2.02 times 10 to the 3, is it? Good. What was the issue with that one, guys? Was it just kind of getting it set up? The diagram was a little bit confusing, the whole way that it was, the wording of the question? Oh, you just forgot to square it. Okay. Okay, so that's just a silly mistake then. You knew what you were doing. All right, the next question we need gone over was number 3 on the front of that page. 3 says a rifle is fired horizontally. The bullet's found to travel 200 meters. So here's the bullet. Travels 200 meters. The rifle barrel is 1.9 meters from the ground. We want to find the speed that the bullet left the ground, left the gun at. So we want to find this speed right here. We're going to set it up the same way. The x and the y components, of course. No funny angles. That's good news because we don't have to do the little aside thing to resolve the funny angles. What equation am I going to use here? V equals. Yeah, good. Got to be that one, right? Because it's a constant velocity. What equation am I going to use right here? Good. VIT plus 1/2 AT squared. Good. All right. V, we don't know. D, we do know. It's 200. It's not 1.9 because that's the y component. T, we don't know. D for the y component is negative 1.90 because it's downwards. VI for the y component is 0. All right. So a half of negative 9.81 is negative 4.905. Take that over by dividing. Square root that to get t. And what do we end up getting for t here? Right? 0.6223. Thank you. Which we're going to take and plug over into here. 200 divided by 0.6223 should give me the answer, which was 321. Good. Anybody want to volunteer what the issue was with that one? Square root. Yeah, you only square root. You don't square root all the time, right? Only square root when we're trying to solve for something that is squared. But don't forget to do it then. Okay, 1, 2, and 3b on the back side of that page. One, a baseball player leads off the game. It's a long home run. The ball leaves the bat at an angle of 30 degrees from the horizontal with a velocity of 40 meters per second. How far is it going to travel in the air? So here's the baseball, 30 degrees, 40 meters per second. We want to know how far it travels. We want to know this distance right here. Got a funny angle, so we got to get rid of that. Go up here. This is 40. This is 30. This is x. This is y. Cosine 30 degrees is equal to x over 40. Who's got that? 34.64 meters per second. Thank you. Sine 30 degrees is equal to y over 40. So y is equal to 20 meters per second. All right. So now we go back and do what we always do. The x components and the y components with the same two equations that we always want to use. Delta d over delta t for the x, VIT plus 1/2 ET squared for the y. V for the x component. Who can tell me what this one is? Bart, what's V for the x component? No. Question number 1 on the back side. Good. 34.64 is the x velocity there. Delta d for the x component, we don't know. That's what we're trying to find. Delta t, we don't know either. Delta d for the y component is what? Allie, what's delta d for the y component there? Yes. It's always 0 when it's launched at an angle. Okay, it's always going to be 0 for us. Now, down the road, take a course in university in physics, you might get something that's launched at an angle from the top of a building, in which case delta D wouldn't be 0 there. But that won't happen to us in physics 20 because that requires the quadratic equation that lots of you haven't even heard of yet, let alone learned. So if it's got a funny angle, delta dy is always going to be 0 for us in physics 20. All right, VI for the y component is 20. Don't know what the time is? Okay, we did one like this yesterday where we divide every term by t. 0 divided by t is 0. T divided by t is 1. T squared divided by t is t. So I'm left with 20, subtract 4.905 t. That goes over by adding. T becomes equal to about 4. Here, Haley, we're not going to square root it, right? Because it's not t squared, it's t. So it equals something around 4, which we turn around and plug into there. 36.64 times 4-ish gives me my answer there, which would be about 141 meters. Make sense, guys? Okay. Question number 3, I'm going to hold off on doing question number 3, actually, because I think that if you can do the rest of these, you can do question number 3. It says, how far downfield does the ball land? Well, you got to get the time, and then you're solving for this. In question number 3b, you're solving for this. Given the horizontal velocity, given the time, solve for the horizontal displacement in 3b. Whoever it was that asked me that, if you struggle with that when I give you some more time to work on that, just ask me again, and I'll help you with it, okay? But I think you can get it yourself now. Question 2 is a little bit different. Question 2 says we get this 170-meter long par 3 golf hole. So we got a ball launched straight here at 40 meters per second at an angle of 50 degrees. The ball goes 170 meters, right? No, it's not what it says. It says the hole is 170 meters. The pin is 170 meters away. So that 170 meters is really irrelevant as far as the projectile motion questions goes. What you want to do here is solve this question just like you do the rest of them. Get this. Okay, what's the displacement? The horizontal displacement. Get that number. Let's say it worked out to be 160. Okay, if it worked out to be 160, then how far is the flag stick away from the ball when it hits the green? 10 meters, right? We just subtract them. So the 170 is irrelevant until it comes time to subtract some numbers. Okay? Pretend it's not even there. Get the horizontal displacement. Okay? Resolve this into an x and a y, and then do your x and y components as you always do. Solve for the horizontal displacement, and then subtract it from 170 meters, and that should give you your distance, okay? Whatever it worked out to be. All right. Sorry I rushed through the last couple of questions. It's just a matter of time here before the end of class here. If those people who asked me those last couple of questions, try them and struggle with them, again, ask me personally again, and I'll help you out with them, I promise. Here's your homework over the weekend in preparation for your test on Wednesday. Okay, please finish up questions 4 and 5 on both sides of the page here. Sorry, I'm lying. I want you to finish up 4 and 5 on the first side of the page and question 4 on the second side of the page. So 3 questions for homework, in addition to starting that process of preparing for your test on Wednesday. All right, that's it for today, guys.